Okay, these are the examples for section 4.3 on right triangle trigonometry. So example 1 wants us to find the 6 trig functions for the triangle. And if you notice in this right triangle, we're only given 2 sides. We need to go ahead and solve for the hypotenuse first. So we're going to use the Pythagorean theorem. So I'm going to set up and say 6 squared plus 8 squared equals c squared. 6 squared is 36. 8 squared is 64, which equals c squared. We know that 36 plus 64 equals 100, which is equal to c squared. And then we have to take the square root of both sides to get c. So c will equal 10. Our missing side is going to be 10. Now that I have all 3 sides of my triangle, I can find the 6 trig ratios. So we're going to start with sine of our angle. Sine is opposite over hypotenuse. So that's going to be 8 over 10, which reduces to 4 over 5. Anytime you can reduce a fraction, go ahead and do so. Next will be the cosine of our triangle. Cosine is going to be the adjacent side over the hypotenuse. So that will be 6 over 10, which reduces to 3 over 5. And then next we'll have the tangent of our triangle. Tangent is going to be opposite over adjacent, which is 8 over 6, which reduces to 4 over 3. Okay, now we can take those 3 trig ratios and we can find their reciprocals just by flipping them over. So the reciprocal of sine is cosecant, so cosecant will be 5 over 4. The reciprocal of cosine is secant. Its reciprocal will be 5 over 3. And then the reciprocal of tangent is cotangent, which will be 3 over 4. So those are the 6 trig ratios that they were looking for this right triangle. Okay, number 2 wants us to sketch a triangle with the given information and find the other 5 trig ratios. So it says that the cotangent of our angle is 3 over 2. And if you remember from our trig ratios that cotangent is the adjacent over the opposite side. So if I draw a right triangle and label from an angle opposite, adjacent, and hypotenuse, I can plug in the values that they gave me. So 3 is the adjacent side and 2 is the opposite side. Now I need to solve for the hypotenuse. So I'm going to use Pythagorean theorem. So 3 squared plus 2 squared equals c squared. So that's going to be 9 plus 4 equals c squared. 9 plus 4 is 13. And then we need to take the square root of 13 to get c. So our hypotenuse is the square root of 13. Now that we have all 3 sides, we can find the other trig functions. We already have cotangent, so we just need 5 answers on this one. So I'm still going to start with sine of my angle. Sine is opposite over hypotenuse. So that will be 2 over the square root of 13. Now it's improper to leave a square root on the bottom, so you multiply top and bottom times the square root of 13, and that will give us 2 square root 13 over 13 when you simplify. Next will be cosine. Cosine of our triangle is going to be adjacent over hypotenuse, which will be 3 over the square root of 13. And when you correct this, it will be 3 square root 13 over 13. The tangent of our angle is opposite over adjacent, so that's going to be 2 over 3. And notice tangent is also the reciprocal of cotangent, so I could have gotten that from the original information. Now we just need the reciprocals of sine and cosine. So the reciprocal of sine is cosecant, and we want to go back to the original fraction that we had for sine, and I want to flip it. If I take the final answer that I had for sine and flip it, then I would wind up with a square root on the bottom. I don't want a square root on the bottom. So we go back to the original, 2 over square root 13, and I flip it. So that becomes square root 13 over 2. Same thing with cosine. The reciprocal is secant. Go back to the original and flip it. So that will be square root of 13 over 3. So these are the 5 trig functions based off of them giving us the cotangent of an angle. Okay, number 3 wants us to complete this table. It's given us a certain trig function. It's given us a degree, a radian, or a function value, and we're supposed to find the other missing pieces. So the easiest way to do this is to use the unit circle, or the information from section 2. So if you look at 45 degrees on your unit circle, that is the same as pi over 4 radians. And then if I want to find the function value, that's the cosine value at 45 or pi over 4. Remember that the cosine is the same as the x coordinate. So the cosine of 45 degrees is the square root of 2 over 2. Okay, the second one gives us the cosecant of some angle equals the square root of 2. Well, I don't have cosecant values on my unit circle. So I'm going to look at the reciprocal of cosecant. If the cosecant of my angle is the square root of 2, then its reciprocal, the sine, has to be the square root of 2 over 2. That's the reciprocal of square root of 2. So now I look on my unit circle for where the sine is the square root of 2 over 2, and that is also 45 degrees or pi over 4. So those are the same angle from the cosine in the first line. Okay, the last one gives us that the tangent of pi over 3. Pi over 3 on your unit circle is the same as 60 degrees. The tangent value, if you remember, is the sine divided by the cosine, so that's going to wind up being the square root of 3. So this is just learning how to use your unit circle and find missing information. Okay, number 4 wants us to use the given function values to find the other function values. So they're telling us that the sine of a 60-degree angle is the square root of 3 over 2, and the cosine of a 60-degree angle is 1 over 2. So this information, I can draw a right triangle and label the sides. So if I go ahead, I can put that the opposite side is the square root of 3, and the hypotenuse is 2, that's from the sine. And then using cosine, adjacent is 1 over the hypotenuse is still 2. So I have all 3 sides of my right triangle. The angle that I have labeled is the 60-degree angle that they gave me. So if I want the tangent of 60 degrees, then I'm going to do opposite over adjacent, which is going to be the square root of 3 over 1. And you can just write that as the square root of 3 if you'd like to. B wants the sine of 30 degrees. Well, 30 degrees is the one that I have not labeled. It's going to be the top angle. And so for the sine of 30 degrees, it's going to be opposite over adjacent. So that'll be, or opposite over hypotenuse, which will be 1 over 2 for 30 degrees. The cosine of 30 degrees is going to be adjacent over hypotenuse, which will be the square root of 3 over 2. And then cotangent of 60 degrees, cotangent is the reciprocal of tangent, so that's 1 over square root of 3, which we would correct and write the square root of 3 over 3. Okay, number 5 wants us to use the trig identities that we've learned in this section to transform the left side into the right side. So all we're doing is going to be showing our steps, working on one side of this equation to get the left side of the equation to equal the right-hand side. Okay, there is no final answer for these types of problems. Your work and the steps that you take is your answer to the problem. So when we're working these problems, you usually want to get things in terms of sines and cosines. So anything that's not a sine or a cosine, we want to get rid of. So I'm going to start with this cotangent alpha. Well, I learned from the quotient identities that cotangent of an angle is equal to cosine of that angle divided by sine of that angle. And in this problem, they use alphas instead of thetas. So I changed cotangent to cosine over sine. I'm going to leave the rest of the equation the same. Times sine alpha equals cosine alpha. Now, if you notice on the left-hand side, I have a sine alpha on the top and a sine alpha that is being divided, or on the bottom. So those are going to go ahead and cancel out. So what I'm going to be left with on the left-hand side of the equation is just a cosine alpha, equals on the right-hand side cosine alpha. So when you get the left-hand side to equal the right-hand side, you're done. You're showing your steps along the way that how you got from the very original equation to the left equaling the right. Okay, same thing on number 6. We're just going to work it a little bit differently. On the left-hand side, we've got 1 plus cosine theta times 1 minus cosine theta. So we're going to go ahead and multiply these two binomials out using FOIL. So I'm going to do first times first. 1 times 1 will equal 1. Then we're going to do outside. 1 times negative cosine theta will be negative cosine theta. Inside, cosine theta times 1 will be plus cosine theta. And then last, cosine theta times a negative cosine theta will be negative cosine squared theta. And this still equals sine squared theta on the right. We're not doing anything to the right-hand side. We're only working on the left. So now on the left-hand side, I want to go through and simplify. So if you notice the negative cosine theta and the positive cosine in the middle, those are going to cancel out. So on the left, I now have 1 minus cosine squared equals sine squared. Now I'm going to go out to the side and do a little bit of work using one of our identities. So earlier in this section, we learned that sine squared plus cosine squared equals 1. I can manipulate this equation and move things around in it, and it's still a valid identity. So if I take this equation and I get sine squared by itself, I would have to subtract cosine squared on both sides. So sine squared would then equal 1 minus cosine squared. This is just another Pythagorean identity that I can use. So anytime I see a sine squared, I can replace it with 1 minus cosine squared, or vice versa. 1 minus cosine squared can be replaced with a sine squared, which is what I can use in this problem. I already have 1 minus cosine squared, so I'm going to substitute in sine squared, which equals sine squared on the right. So I'm not changing my equation in my original problem. I'm not moving the cosine squared over to the sine squared side of the problem. I have to leave the right-hand side exactly the same. We just substituted a Pythagorean identity that was equivalent. Okay, number 7 wants us to use a calculator to evaluate these trig values. So make sure that you are in degree mode. Notice both of these are in degrees. One looks a little bit different on B, but we'll get to that one. So on A it says cotangent of 11 degrees. Well, if you notice, you do not have a cotangent button on your calculator, so we're going to have to use some reciprocals here. Cotangent we know is the same as 1 over tangent. So when you type this into your calculator, you're going to type 1 divided by tangent of 11 degrees. So go ahead and type that in. And we're going to round to 4 decimal places. Because we are rounding our answer, we're going to put approximately. It's not going to equal a certain number unless it's a whole number. Most of the time these are going to be decimal answers. So if I round this to 4 decimal places, I'm going to get 5.1446. Okay, now on B, I have the cosine of 4 degrees, 50 minutes, and 15 seconds. And we saw this type of notation in a previous section. So as I type it in the calculator, I'm going to go ahead and account for the degrees, minutes, seconds. So cosine is what I can type first. And then I'm going to type the degrees as they are, plus 50 over 60, that's the minutes, plus 15 over 3600 is the seconds. So if you go ahead and type that in at one time, then we can find the approximate value of the cosine of this angle. So again, we're going to go to 4 decimal places. So this is going to be 0.9964. Okay, number 8 wants us to find the value without a calculator from the first quadrant. So this is using our unit circle. So if you look in quadrant 1 of your unit circle, I'm trying to find what angle has a sine of 1/2. We know that the sine is the same as the y value. So if you see sine of 1/2 is at 30 degrees, which is also pi over 6. So we're going to write it using degrees and radians. 30 degrees and pi over 6. Part B wants us to find the angle that has a tangent of square root of 3. So remember, the tangents are the sines divided by the cosines. So sine divided by cosine to equal the square root of 3 is going to be at 60 degrees or pi over 3 radians. So just learning how to use your unit circle and find the missing information that they're asking you for. Okay, so your homework is on page 308. You're doing 2 through 66, every other even.